This is question 6 from a C123 January 2013 paper. It's a chemistry module 3 topic. Parts A and B are all about rock salt and how we use it and one of the methods of mining it. This is your cue to revise that, but basically it's drawing on the ideas that rock salt can melt ice and give improved grip on the roads, but that it's also impure. It contains grit, so it's not fit for the food industry. The question on solution mining in part B requires you to, for 2 marks, say that water is pumped down and then think about the process. That water dissolves the salt. Then the water gets forced back up under pressure and you now have salt solution. And in part 2, the problem that can happen in the environment because of solution mining is that the salt can get removed from rock below the surface of the earth, and gaps are therefore opened up as that salt is dissolved. And this can cause the ground above to collapse. You could get a sinkhole. You can also give a sensible answer about the big artificial ponds and lakes that form after solution mining, and these could then collapse and or become unfit for the local wildlife. This next part of the question is a really good way to revise the electrolysis of salt solution. It gives you a comprehensive diagram of an electrolysis cell and asks you to label what chemicals would be at A, B and C. It even gives you some chemical names to choose from. So having a look at the diagram, in part A, it's a gas that can leave through that outlet, and they've already labelled hydrogen on the diagram, so we need to find a gas that's relevant to this process from the words listed, and that's chlorine. Now looking at outlet B on the diagram, this is where a product is going to be leaving the cell, and it's a product that dissolves in water. The whole point of the electrolysis of brine, when you've got the membrane there, is that you're making the alkali, sodium hydroxide. So that's what's going out in solution in water through port B. Finally, we need to see what's coming into the electrolysis cell at point C. Well, our starting material is sodium chloride dissolved in water, and sodium chloride is one of the chemicals listed, so that's the one we need to go for. At this point, the mark scheme says don't accept brine in box C. Brine is really concentrated sodium chloride solution, but more importantly for this question, it's not one of the words given on the list, so make sure you're also following the instructions that the exam question gives. Now, another reason I really like this question is that the diagram for the Leblanc process is one of the clearest that I've seen on the course. So you might want to press pause and note down this diagram for your revision at this point anyway. The question itself is 2 marks, and it says, use a diagram to suggest 2 other reasons, other than the salt deposits in the northwest of England, why the alkali industry developed in the northwest of England. So looking at the diagram, looking at the raw materials, we've got salt and sulfuric acid going into the furnace, and some hydrogen chloride waste comes out. And then we need to add some limestone and some coal, and then we put it into this black ash revolver with calcium sulfide waste to get our end product, the alkali sodium carbonate. That's the whole point. Well, it's also true of the north of England, which you'll have learnt about in the geology section of C3, that there is a lot of limestone and a lot of coal. And indeed, if you just write those answers for numbers 1 and 2, you will get both marks. It doesn't want you to explain that. It wants you just to name the 2 resources. Now, if you go back in and fill in your answers for the very first parts A and B, 1 and 2, how many marks out of 10 would you have got?
Made with Doodlecast Pro.